Hey everyone, welcome back to the College Algebra playlist. In previous videos, we gained mastery over solving linear and quadratic equations. Alright, in this chapter in the textbook, we're moving on to some more challenging equations. Alright, equations that are harder to solve. Alright, and those include rational, radical, and absolute value equations. Alright, so let's dive into radical equations right now. Okay, here we go. Radical equations. Radical equations are equations that contain variables in the radicand, all right, which is the expression under a radical symbol. All right, here are some examples of radical equations, right? The black equation, the blue equation, and the red equation are all examples of radical equations because they involve radicals and they have variables under those radicals. All right, so how do we solve something that looks like this? We can solve radical equations by eliminating each radical one at a time. How do we do that? We isolate the radical, then raise both sides of the equation to the power needed to eliminate that radical. All right? And the result of that is that we get an equation that we know how to solve. All right? Linear, quadratic, etc. So then we solve, then check the solutions since extraneous solutions can occur. All right? I talked about extraneous solutions in depth in the previous video, right? That's video 34 in the playlist. All right, so if you want to find out more about extraneous solutions, go check out that video. All right, but basically, extraneous solutions, they arise after we perform algebraic steps, and they appear to be valid, but when we check them in the original problem, right, they don't satisfy the equation. Okay? So that's why we need to check our solutions when we solve rational and radical equations. All right, here we're asked to solve for x. All right, so we're about to try solving our first radical equation. All right, the goal is to isolate the radical on one side and then get rid of it. All right, it's already isolated, right? It's already on the left-hand side. So to get rid of the radical, what we need to do is square both sides. All right, that gives us this. All right, and when we square a square root, right, they undo each other. Right, the square root and the square power, they undo each other, and we're left with 15 minus 2x on the left-hand side. Okay? And that's equal to x squared. So then we realize that we have a quadratic equation to solve. All right? So let's put this quadratic equation into standard form. All right, I'm going to swap the left and right-hand sides here. And then we want this to be set equal to 0. So we take the negative 2x to the other side, and we take the 15 to the other side to get this. All right? This expression on the left-hand side is factorable. All right, we can factor it as x plus 5 times x minus 3. All right? So by the zero product property, this equals 0 or this equals 0, right? Which means that x equals negative 5 or 3. All right? So we get two solutions here from the resulting quadratic equation after squaring both sides. All right? So we need to check both of these potential solutions since the original problem was a radical equation. All right? Let's check x equals negative 5 right now. All right, we're going to plug it into the slots wherever we see x in red. All right, and we're going to see if we have a valid equation. All right, do we have a true equation? That's the question. So when we plug in negative 5 in red here, this is what we get. All right. Under the radical, right, we have 15 plus 10, all right, which is 25, all right? So we have the square root of 25, and we get 5 on the left-hand side, and that is not equal to negative 5. You say, Luke, how about a plus or minus here? Shouldn't you put a plus or minus when you take the square root of 25? And the answer is no, we don't do that. All right, we only include a plus or minus when we're solving for an unknown variable. All right, if we're trying to isolate x and solve for it. All right, here we're simply evaluating numbers. All right, we're plugging a value in and then we're evaluating. So in that case, we need to take the principal square root, which is just 5. All right, so 5 does not equal negative 5. So that means that x equals negative 5 is an extraneous solution. All right, so we throw that in the garbage. Let's check x equals 3. All right, when we do that, we get this. All right, and we perform the subtraction under the radical, right? 15 minus 6, that is equal to 9. So we have the square root of 9 equal to 3. The square root of 9 is 3. So we get a true equation, right? We get 3 equals 3, which means that x equals 3 is a valid solution. All right? Let's move to a harder problem. All right? This one is pretty challenging. All right, so fasten your seatbelts. Basically, what we're going to do is eliminate each radical one at a time. Okay? So it doesn't matter which one we choose to isolate first. All right? But for this problem, I'm going to isolate this radical first. All right, I'm going to have square root of 2x plus 3 equals 4 minus square root of x minus 2. All right, so we just subtracted both sides by square root of x minus 2. Okay? So now that we have one of our radicals isolated, what we want to do is square both sides. Get rid of this radical here. All right, when we do that, this is what we get. All right, on the left-hand side, we just have the square root of something squared, right, which is just the something. Okay, but on the right-hand side, we have something that we need to FOIL. All right, 4 minus root x minus 2, whole thing squared, looks like this. All right, so let's FOIL this right-hand side and see what we get. All right, for my firsts in blue, I have 4 times 4, that's 16. All right, and for my outers in red, I have 4 times negative root x minus 2. All right, so we just get that product in red there. All right, for my inners, I have this expression in green times this times 4 in green. All right, so that gives me negative 4 root x minus 2. Okay, and for my lasts in purple, right, I have this times this. All right, a negative times a negative, that's positive. And look what we have. We have root x minus 2 squared. All right, we're multiplying it by itself. So that's just going to give us the business under the radicals, right? That's going to give us x minus 2. All right. Next, we notice that we have some constants that we can combine, right? We have 16 minus 2, all right, that'll give us 14. And then these expressions in blue, right, we can treat these essentially as like terms. All right, we have negative 4 times something, minus 4 times that same something. All right, so we can combine the constants in front to get negative 8 times the something, right? Root x minus 2. Okay, let's take this result to the top of the screen. All right, we got rid of one radical, all right, by isolating it and then raising both sides to the 2 power. All right, but we have another one. We have another radical that we need to get rid of. All right, so let's isolate it on the right-hand side. All right, let's subtract x from both sides and subtract 14 from both sides to get this thing by itself on the right-hand side. All right, and we get 2x minus 1x, right, which is 1x. All right, and 3 minus 14 is 11. Okay, so that is equal to negative 8 times the square root of x minus 2. All right, so we have the radical isolated, so now we can square both sides to see what we get. All right, on the left-hand side, right, I get x minus 11, whole thing squared. And then this, right, when we multiply this by itself, we have negative 8 times negative 8, which is positive 64. And then we have root x minus 2 times root x minus 2, which just gives us x minus 2. Okay? The square root of something squared is the something. All right? On the left-hand side, right, we have something that we need to FOIL. All right? I'll skip the foiling process for the sake of brevity, but this is what we get on the left-hand side after we FOIL this expression right here. All right. And then on the right-hand side, we distribute, right? We get 64x minus 128. All right. So now look at this. All the radicals are gone, and we're just left with a quadratic equation. All right, we know how to solve quadratic equations. Let's put it in standard form. All right, we're going to subtract 64x from both sides and add 128 to both sides. All right, and that gives us x squared minus 86x plus 249 equals 0. All right, let's take this result to the top of the screen. This expression on the left-hand side is factorable. Right? We can factor it as x minus 3 times x minus 83. All right? So that gives us the solutions 3 and 83. All right? We need to check both of these potential solutions, right? Because the original problem was a radical equation. All right? So let's start by checking x equals 3. All right, we're going to plug it in everywhere we see x in red here. All right, this is what we get when we plug in x equals 3. All right, so we get square root of 9 plus square root of 1 equals 4. All right, we want to know if that's a true equation. Square root of 9 is 3, and square root of 1 is 1. So we get 3 plus 1 on the left-hand side. And look at this. We get something valid, right? This is a true equation. 4 does equal 4. So that means that x equals 3 is a valid solution. All right. Let's check x equals 83 now. All right, we're going to plug in 83 everywhere we see x. All right. So here we have this. Under the square roots, right, we get square root of 169 plus square root of 81. So we get 13 plus 9 on the left-hand side, all right, which is equal to 22. So 22 does not equal 4, all right? We're getting a false equation here, which means that x equals 83 is an extraneous solution, all right? So there's only one solution to the original equation, and that's x equals 3. All right? That does it for this video. Thank you for watching, and like and subscribe.